triangle to the right to find the length of the missing leg. So here we can see we have a right triangle, which is denoted here by this right angle symbol. So when we have a right triangle, we use the Pythagorean theorem, in which is a squared plus b squared equals c squared. C is always going to be our hypotenuse, which is always going to be opposite the 90-degree angle. Our hypotenuse is always going to be the leg opposite of the 90-degree angle. The squared length of the hypotenuse, which is c squared, is equal to the sum of the squared length of the legs, which is a squared plus b squared. Another way we can say this is, in any right triangle, the sum of the squares of the lengths of the legs, which is a squared plus b squared, is equal to the square of the length of the hypotenuse, which is c squared. So when using that, we're going to use the Pythagorean theorem to find the length of the missing leg, because this is a right triangle. Now let's remind ourselves, the Pythagorean theorem is a squared plus b squared equals c squared. And we've already defined in this diagram or picture that c is our hypotenuse. So here we have a squared plus b squared equals c squared. We're going to substitute our constants for the variables here, or our numbers for the variables here. So instead of a, we're going to write 6. We're going to substitute in 6. And instead of b, we're going to write 8. We're going to substitute in 8. And everything else will remain the same, equals c squared. 6 squared is equal to 36. Plus 8 squared, which is equal to 64. When we bring down our c squared. (36 plus 64 is 100 equals c squared. Now, if you're familiar with perfect squares, we already know what this answer is, but we're going to keep going and solving for those who are not too sure. To get c by itself, we have to take the square root of both sides. So square root of 100 is equal to the square root of c squared. Square root of 100 is 10. And the square root of c squared is c. So 10 is equal to c, or c is equal to 10. Let's look at our next problem. A equals 8, b equals 15. Let's remind ourselves of the Pythagorean theorem. A squared plus b squared equals c squared, in which c is our hypotenuse. We're going to substitute in the values for each variable. Instead of writing a, we're going to write 8. So it's 8 squared. Instead of b, we're going to substitute in 15. So that'll be 15 squared. And everything else will remain the same. 8 squared is 64. Now, what is 15 squared? Well, let's see. 15 times 15 we're going to do 5 times 5 is 25. Write our 5. Carry our 2. 5 times 1 is 5. Plus 2 is 75. Write our 0. We're going to start in the tens place. 1 times 5. 1 times 5 is 5. And 1 times 1 is 1. Then we add the 2 together. And we get 5 plus 0 is 5. 7 plus 5 is 2. Carry our 1. And 1 plus 1 is 2. So the square root of 15 is 225. So now we have 64 plus 225 equals c squared. Now 64 plus 225 is equal to 289. Okay, now to get c squared by itself, we have to take the square root of c. And what we do to one side of the equal sign, we do to the other. So the square root of 289 is equal to c. Now we look for perfect square factors. It's not popping out at me right away. Let's see if 3 goes into 289. 3 goes into 28 9 times. 3 goes into 19 6 times, which gives us 18. So 3 is not a factor of 289. Let's see, what about 9? Is 9 a factor of 289? We know an even number doesn't go into 289. 9 goes into 28 3 times. 3 times 9 is 27. Oh, we're back in the same boat. 9 goes into 19 twice. Alright, let's try 7. 7 going to 289. 7 goes into 28 4 times. But 7 is not going to 9 an even amount of times. So 7 is also not a factor of 289. However, there is a factor of 289. Let's try 17 times 17. Let's go for perfect squares. 7 times 7 is 9. 49. Carry our 4. 7 times 1 is 7 plus 4 is 11. 1 times, and then we put in a 0. Cross out our carry from our previous computation. 1 times 7 is 7. 1 times 1 is 1. That gives us 289. So C is, square root of 289 is 17. C equals 17. Our next one here is A is 1.5, B is 2. So we're going to rewrite our Pythagorean theorem, which is A squared plus B squared equals C squared. Instead of A, we're going to write 1.5 squared plus B squared, which is 2 squared plus C squared. Now earlier we did 15 times 15, which is 225. And 1.5 times 1.5 is going to give us 2.25. Plus 2 squared is 4, which equals c squared. And then 2.25 plus 4 is equal to 6.25 equals c squared. To get c squared, c alone, we take the square root of both sides. So square root of 6.25 times, well, equals the square root of c squared. All right, now we know 17 times 17 equals 289. 15 times 15 equals 225. 20 times 20 equals 400. Let's see, what's 25 times 25 equal? 5 times 5 is 25, right? Our 5 carried a 2. 5 times 2 is 10, plus 2 is 12. Now we scratch out that carry. Put our 0, go to the tens place. 2 times 5 is 10. Write our 0, carry the 2. 2 times 2 is 4, plus 2 is 6. 725. So that isn't it. But also, we aren't looking for let's check our math. 5 times 5 is 25. Write our 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Okay, got that? 2 times 5 is 10. Write our 0. Carry the 1, not the 2. And 2 times 2 is 4, plus 1 is 5. Which gives us 625. But this is 6.25. So we're going to change that to 2.5 times 2.5. Which would equal to 6.25. So square root of 6.25 is going to be 2.5 equals C. Great job, everybody.